many fractions containing two spots on each of them. And as you can see in this picture, this is the mixture crude, and this is starting material, which is Roman charcoal, and it shows up on the very top of the plate among these spots. And I can say this Roman charcoal is not matching line up to with this crude. So it's a good thing that the fractions I got doesn't contain starting material. But I can still see a lot of fractions having two spots on each plate. So I purified those fractions again using different solvent. So for this purification, I use 3:7 ratio of acetate and pentane solvent. But for this one, I use 1:9 ratio of acetate and pentane. And I got finally just only one fraction here. And I also use dyes to see if there are more spots on the plate, and it doesn't show any spots except this spot from the UV light. So after the purification and TLC, I checked the purified fraction with IR, and the peaks of IR didn't match it to the paper. So I thought maybe that product is not the product that I want to have. So it was frustrating. So we move on to the other and last protocol we found by direct men. And scheme here look slightly different than the other two, but basically they're similar. And differences between this paper and the others is using this another reagent, and this reagent is called THP, and it has a role of protecting group. So this compound, this structure protects this alcohol, and it makes the intermediate structure more stable. And I started from this compound to synthesize this reagent, and I mixed the format charcoal and this reagent and this potassium carbonate to make a reagent synthesis for 24 hours. Yeah, so at this point, the reason why I spent 24 hours is to kick off this chlorine up into the paper. So, yeah, this is intermediate structure. The procedure is similar but a little bit different. So first I synthesized reagent number 7, and I did reflux. In this case, I just heat, and I kept the temperature at 120 degrees Celsius for 24 hours. After 24 hours, I extracted and washed it, and I got organic layer and concentrated, and I got really deep brown viscous oil in this case. And I didn't do the purification process in this case because the paper said just I can use this concentrated product can be detected by IR and NMR. So I checked with IR. As a result, I got these peaks. Even though there is a negative peaks here, but I thought it was good because I had a lot of failures from the first and second paper, so I thought these peaks are good. And the first around this area is meaning alcohol group, and next peak around 3000, and sp3 H as carbon and H stretch. And here's 1650 area, is meaning carbon-carbon double bonds. And lastly, 1000 this area is meaning hopefully ether. And so when I compare these peaks to the paper, and also major peaks like this are matched together. So I thought this was a good thing. But the problem is that this peak has this arc group. And if we back to the skin here, and the peak is of this compound, and this compound doesn't have an OH group in it. But I detected an IR OH group, and also the paper said they also found OH group in their product, even though this compound doesn't have OH group. So honestly, I don't know why they said maybe the product has OH groups in it, but still my product peaks is matching to the paper. So I think I was better to use NMR to make sure the structure of the product. So what are some challenges during the whole research so far? I was having a hard time on purification process. Somehow I couldn't purify really well on the first paper. I got a bunch of different fractions after purification, even though I used different solvent. So in order to overcome these challenges, I found second paper. Actually, the reason why I found second paper is not from this, but as a result, I could purify the one fraction from the mixture too. And next challenge is limitation of using organic spectroscopy. So we have NMR and IR, but for my product, the NMR cannot detect my product because the NMR we have only can be used for oil example, but my product was powder. But that could be a limitation in my research. But for the last paper, the product was oil sample. So in the future, I can use that sample to the NMR detection. How this can be overcome. And finding the paper, I thought it worked. Because I found the last paper that gave me better result than the others. And using other spectroscopies rather than IR, NMR is the best option for any organic reactions. So what should be done in the future? So I need to progress and finish the carbon synthesis using the protocol by direct map. After I synthesize this compound, then maybe I can design and think about how I'm going to synthesize analogs of carbon in the future. So this is all the text that I have done so far. These are references that I use. Special thanks to Dr. Kwong and Dr. Luko I just really appreciate that I can have this great opportunity to do my own research. This is why I came this year. Why in Korea it's really hard to find any places can provide students with some research opportunities as an undergraduate scholar.